I don't know though, which one did you do for the extra credit, either population mean or population proportion? So I'm gonna send you one of each. If I send you the template for one population proportion, that means I want you to do population mean, and vice versa. I'm thinking population mean. But I'll see. I have to take a look. I gotta take a look. But I will have a template for you. Of course, your question is not going to be the same as the template, but I just want you to know, I just want you to show you how I want your work to be, especially people who do R. And I have to do the video for you too. But if you can use calculator or you can use Google Sheet, right? You don't have to use R if they're not comfortable for you. Yes, fine, Larissa. You're sick, I don't want you to come. Just don't make it habit. People, when they're sick, I prefer like you have some kind of COVID test. So I know that you're not just saying you want to stay home, especially quiz day. I don't mind if you stay home on the non-quiz day, but quiz day, I want you guys to be here. I try to be fair to everybody. Do you have any question from the last chapter 16? All right, okay, chapter 17. I'm sorry, yes, chapter 17. So test of significance. A lot of time I'm gonna say hypothesis test. Actually, I'm gonna say hypothesis test. I rarely say test of significance, just because I like it better. Now there are two ways to do statistical inference. By the way, what is statistical inference again? Remember? About use what, infer about what? Say one more time. You use sample to infer about information about population, right? Why? Why don't we just use population to infer about population? It's difficult, right? It's difficult. Sometimes it's impossible, right? It's costly. Sometimes it's not even possible to do so. So last time we did cover intervals. This time we're gonna do hypothesis tests. Okay, so here is the step of hypothesis test. In this class, I believe you guys have at least two types of hypothesis tests. One population mean. Let me highlight it here. I'll use plural. So you're gonna have one population mean and one population proportion. Actually, the three of them. And then pair mean as well. You have three hypothesis tests. For one population mean, you're gonna have two tests. It's gonna be a Z test or a T test. I'll tell you when you're gonna use Z test and when you're gonna use T test. Okay, of course on the exam, I'm not gonna tell you which test you're gonna use, but you have to figure it out yourself. And for proportion, for pair mean, well, that's later. But right now, it's one population mean, either Z test or T test. Today, we're gonna do Z test. Okay, so that's the little trees. Second step is checking the assumption. I will tell you what you need to check and what you don't have to check. And then step number 3, you calculate the test statistic. Can someone tell me what test statistic have we already done? No, that's sample statistic. Yeah. Test statistic. Test scores. That is the Z test. So far we did the Z test. That's all the tests that we did. Later we have T test, we have F test, chi-square test, but I don't think you're gonna do all that. Maybe T test, not F test. And then last but not least, once you calculate the Z test, you look up on the table, right? You have the probability, and that probability is called p-value. And based on the p-value, you make a decision, right? Based on the step 4, you make a decision and conclusion. So step 4, make decision. I'll tell you what kind of decision we make, and conclusion. Yeah, but that's the step. I'll remind you the 4 steps throughout the slide. Don't worry, you don't have to remember. Just kind of ingrain your brain. After several times, I remind you. Okay, step number 1, determine the appropriate no and hypothesis. So right here, no and hypothesis. No is denote H naught, and hypothesis denote HA. That's your second slide. So the no often denote H naught, and it's inferred to the statement saying no effect, no difference, nothing has changed, nothing's happening, so it's boring. H naught is boring. If you see the next slide, H naught is all equal, mu equal mu naught. That's basically the status quo, right? For HA, more interesting stuff is the thing that you want to show. Alternative hypothesis is often denote HA, and it's a statement that there is a relationship, there's something different, right? Something bigger or less than, something happening. Right? And usually the scientist or the researcher hopes the evidence will be strong enough to reject H naught and support HA. H naught is boring. It's nothing. When you write the statement about H naught and HA, make sure you write it in population parameter term. Like right there, down there. See, I don't use X bar, I use mu. And mu naught should be given in the problem, but you have to be able to spot mu naught. Like, it's not gonna say mu naught equal, but you should be able to spot how. Take practice. And HA is the direction of extreme. When I say extreme, it's gonna be if it less than, say mu less than mu naught. So you want this part. Oops, sorry. You want this part, right? You want the left tail. Is it mu less than mu? You want the left tail. If it's greater than, you want the right tail. If it's greater than, you want the right tail. Sorry, my picture is not perfect. And if it's different, mu is not equal to, then you want the 2 tails, right? You want 2 tails. And that is your p-value. The little things I highlight in blue, that's your p-values. And how do we find p-value? It's going to use the z-test. So far, so good. Pretty simple. All right, I'm going to do number 1, and then you guys are going to do number 2. Campaign require money to get their messages to voters. Some voters are eager to make monetary campaign contribution to political candidates through small donations. Small donors are people who are more like the average voter. The average monetary contribution to political candidates made by small donor is $61. That's your mu naught. Right? The average money, right? The average, the mean mu. You highlight here. That's your mu naught. We would like to access if the population, by the way, when you hear access, that means I'm asking you to do hypothesis test, not confidence interval. Right? Access. If the population average monetary contribution to political candidates made by young donor between 18 and 30 years old, significantly lower than the stated small donor monetary amount of $61. So mu naught is $61. And the one I highlight in red, that's your alternative hypothesis. So HA is easy. HA is just say mu is equal to $61, right? Mu equal mu naught. By the way, the one I write in black is just one formula. You don't have to show me that. Just I want you to remind you, that's all. Then HA is, well, I want to know if the true mean average of the contribution is significantly lower than the say the small donor, right? So I hear lower mean less than $61. What kind of tail I have here? Left tail, right tail, two tails. Left tail, right, left tail. Did I skip a slide or something? No, I didn't. No, I didn't. I did not. All right. All right. So that's my H9 and HA. Crazy. That's easy. The parameter here is mu. The one I'm interested in, mu, is mu. And mu is, what is mu? Well, it's the population mean, or sometimes I call it true mean. And then now context, what true mean monetary contribution. Contribution to political candidate. Okay, last exam. Let me finish this sentence. Made by young donor. Young small donor. Who knows? Between 18 and 30 years old. Last exam, you guys, number 2. It was about the encourage eating. I forgot, what was that? I forgot what was. I have a student exam. Oh, about the healthier snacks. And a lot of people just say P of A, even P of B, which I had no idea what A was B. So you have to either you label to me which one is A, which one is B, or just write out, okay? Or just say something that imply that you meant this event. If you say A and B and I have no idea what you were talking about, I cannot give you a partial credit. Like this, I can't figure it out. All right, you gotta try number 2 and put it in the chat for me. So this exam, I'm gonna be last exam. I'm okay. I'm just kind of not care much about the context, but this exam I will. It's important because confident interval interpretation, confident level interpretation, conclusion, which is later. your exam. If you don't have your exam, please come to me. Brandon. All right, Brandon. Roman last. C. That's the paragraph then. Yep. Yep. Volunteer. Your first name is Mallory. Mallory, okay. Oh, Kareem?
Yeah.
What's your last name, Kareem? I'm over here. Is that your handwriting? Oh, okay. Kareem. Okay. J. Oh, your last name? Oh, okay. I see. Yeah, I'm gonna.
Okay,
Carly. Okay,
Yes.
thanks. Sorry, Carly.
No,
I promise tonight I have
Okay.
it.
Rosa.
Rosa.
Ella.
Ella? Anyone else? I got Madison, Ryan, Mohammed's not here. I'll talk to that dude. All right, let me see what you guys have. Let me read. Forgot what. All right. Okay. Stephanie, right? Steph. What was it, Stephanie? Is it H not? Is that what you're saying? H not? Do I want less than on the exam? I don't think I'm gonna take the points off, but I prefer just equal. It's a status quo. So yeah, because it's there's no change, no nothing. So I would prefer equal instead of less than. For equal. Make sure you say H not. Mu is a true BMI of adult males is very good. Yeah, very good. H not, you forgot your mu, Rami, forgot your mu. Yeah. True mean of adult BMI in what year? 2018, right? Because there are two of them. That's what I meant by I'm gonna focus on context a lot for this exam because I need to be exact. What you really truly understand what you're talking about. Same thing with Tyler. Forgot mu. True mean is very good. If forgot mu, I'm sorry, I forgot mu for the for the first one. Maggie, Brandon, same. What's up with that thing? You got mu for the second one, but not for the first one. No, mu. H not is just H not. HA is the hypothesis. Yeah, it's a name. It's a name. Yeah. You should not put H not equal. H not colon. Again, what year? Right. Thank you. Okay, so some of you got the idea. So I know this is right here. This is my mu naught, right? This mu naught. So H naught is mu equal mu naught. So mu equal 33.7. And here, because the researcher want to know if BMI for all US male adult in 2018 is more than it was a decade ago, I'm gonna highlight that. So mu is greater than mu 2018, right? Greater than 33.7. And mu here, parameter of interest, is the true mean or population mean, BMI for all US. Make sure you say US, not Mexico, not China, right? US male adult. There's no S in male. In 2018. Every time I wear this thing is my nose running. It must some kind of particle. Okay. So from the two example, you see, if you look at the HA, so far we did what? We did one-sided, right? So the second one, it was the right tail because it's greater than, and then the first one, it was the left tail, right? But only one side. So if you have a single direction, then the test is called one side or one tail test, one tail hypothesis test. If it both direction, which I'm going to show you later, if in both direction, then the test is called two side or two tails. It's more like terminology. When I say two-sided, then you should supposed to know that I talked about my HA is mu is not equal to mu naught. For expressing your null hypothesis, like I said, I prefer use set the population parameter, which is in this case mu. Later you're gonna see a different population parameter, right? Proportion. You're gonna see mu equal mu naught, no values. I don't want it. Sometimes we do less than equal to. I don't like that because I'm trying to emphasize no is this is status quo. It should be just equal. Some professors accept that though. Now, when we talk about hypothesis, we always assume that H naught is true. And what you try to show is you try to show HA is true, right? You try to overwhelm in H naught, reject it, and then favor HA. If in criminal justice system, I want you to think of this: H naught is the defendant is what, innocent until proven guilty, right? So H naught is the defendant is innocent. HA is defendant is guilty. That's how the criminal justice system works. Right? You always assume that the person is innocent until they found evidence that overwhelm that whatever they tried to show, then they're proven guilty. So we assume that the null hypothesis is true until the sample data provides sufficient support. Otherwise, overwhelming evidence, right? If it does indeed too overwhelming, then you allow to reject H naught and support HA. Now, let me ask you a question. If I reject H naught, does it make HA true?
Not necessarily.
Because no, right? We just say we reject H naught, we support HA, but doesn't mean that HA is true, right? A lot of people go to jail for things that they haven't done, right? That's why capital punishment is rarely applied to people. What if a guy is innocent? Right? 10 years later, they found out he's not. He's innocent. You already killed him. So when you reject H naught, you just favor HA. You support it, but it doesn't mean that it's 100% true. Okay, now the question is that what is the percentage that I can reject H naught? That's important, right? So if the null hypothesis is true, then what is the probability the observing sample data be more extreme? This telling you that what is the probability that I can reject H naught and favor HA, which come to the test statistics, right? We're gonna calculate some number, and we're gonna make a decision when we're gonna reject H naught or fail to reject H naught. So test statistic is calculate from the sample data, measure how far the data diverge from what we expect of the null hypothesis. This sentence sounds fancy, but you guys actually already did this. Is calculate, remember test statistic, tell me the z-scores. Can someone remind me the z-test? Z equal. Okay, x minus mu divided by, just say sigma, okay, the sigma divided by square root of n, but let's just say sigma for now. So z is your test statistic, and it is calculating equal from the sample data measure. The sample data is x, when you observe value. How far the data, that's your data point, that little x, diverge from what we expect of the null hypothesis. Null hypothesis if the null is true. So sample statistic, that's your x. I would say x bar. Maybe we use x bar, maybe it's the second one, x bar divided by square root of n. Maybe I'll use that one. Null value is, so I'm gonna highlight in green. Later you're gonna see it's gonna be mu naught. It's gonna be mu naught. You can see that. Mu naught, which is down here, but don't worry. Right there, mu naught. That's your null value. And no standard error. It's just a fancy way of saying your sample standard deviation. I don't know why they make it so complicated. That's right there. Sample standard deviation. There are three types. Sigma is, let me put it right here. In purple, just recall stuff. Sigma is stand for what? What type? Population, right? Population SD. I don't have enough space. Sigma divided by square root of n, that's sample. Can't write it correctly. Sample SD, sample standard deviation. And then later you're gonna see S divided by square root of n. It stands for the standard error. Which don't worry, later I'm just giving you a heads up. You're not gonna see it today. Maybe it's Thursday. So just make sure you know three types. Okay. Population standard deviation. Sometimes you have it, sometimes you don't. Sample standard deviation. Sometimes you have it, sometimes you don't. Depends if you have sigma. Right? Standard error is the estimate of standard deviation. You always have it. Always have it. Its little s is what? Sample standard deviation, right? So you take somebody out from the population, you have sample size, you can calculate the little s. This estimate this estimate this. Okay. And last but not least, the p-value. Once, let me go. I think I want to go to this slide first. I should have put this slide up there. So here is the one sample z-test for population mean. It only applies. By the way, I'm talking about population. It only applies if you know sigma. If you don't know sigma, you're gonna use t-test. Do you guys remember the first slide that I told you, the little tree there? When do you use z-test? Or today gonna use z-test? Because I'm gonna give you all the sigma. When you don't know z-test, I'm sorry, when you don't know sigma, you use t-test. I should have put this slide right here next to this one. I'll fix it maybe for next class. I think I like that better. Okay, so the one sample z-test, it has this formula. You don't have to memorize if you can. Great for you. If you don't, it's always in your stat card. Mhm. And we only use it if you know sigma. Okay, so using this one, punch in a bunch of numbers, you got z. What are you gonna do? You look up on the z table, right? And then you found the little value probability is called p-value. I'm gonna explain p-value later, not now. I don't want it overwhelming you. You're probably not gonna understand what I'm saying, but I'm gonna explain it to you later. For this part, if you read it, you understand, good for you. If you don't, it's not important. Okay. You will know, but not now. So the p-value is a probability, so naturally it's between 0 and 1. Okay. P-value is not a probability that the null hypothesis is true. It's a probability that you can reject the null hypothesis. Actually, I shouldn't highlight that thing. P-value is the probability that you can reject. I would say probably I don't like my language. Probability. I don't want to use borderline either. Then you're going to confuse the other one. What should I use? The least probability. You're probably confused now, but you're gonna be under you know why in a second. The least probability. Yeah, that better. I like that. Reject is not. You understand what later. All right. The smaller the p-value, the stronger the evidence against H naught. Remember, p-value is the error that you convict people, right? If the error is small, no, p-value is the error. It is error. Yeah, p-value is the error that that person is innocent. The person is innocent. If the error is small, the smaller is the better, right? You have stronger evidence to convict that person. Common convention, reject H naught if the p-value is less than or equal to some borderline value. And I'll tell you what the borderline values are. It's given, it should be given. You should not guess this. If you don't see on the exam, you kind of let me know. But I don't know why I forget, but it should be in the problem. It should be given in the question, always. And the borderline value is called, the significant level. And it's denoted by alpha. That's the first letter of Greek alphabet. Does anyone hear Greek? Greek? No Greek? Re alpha. So remember, we say the reject H naught if the p-value is less than or equal to the borderline. So if p-value is less than or equal to alpha, this borderline is alpha, we say the result is significant. Right? So this part right here, you reject H naught. Right, that's what we say up here. Then we say the result is significant. It's exciting when you reject H naught. If you don't, if you fail to reject H naught, it's nothing exciting. Right? The common level of significant level are 5%. And for me, 5%, 10%. You're not gonna see anything other than that. I think for most of the statisticians use that too. I've never seen like 7% or 8%. Rare. Maybe in biology, people use that. All right, so p-value less than or equal to alpha, we reject H naught. Remember, the smaller the p-value, the stronger your significance at level alpha, right? If p-value is greater than, I'm so sorry, it should be greater than no equal sign. That would be confusing. Oh, sorry. I have an idea. I'm gonna cheat a little bit here. There, greater than you white paint. If it p-value is greater than alpha, we fail to reject H naught. And because we fail to reject H naught, you say the result are not statistically significant or insignificant. Don't worry if you're a little fuzzy, it'll help you later, okay, when you do problem. And don't worry, and you're gonna have a lot of chance to talk about p-value a lot, at least 4 more lectures. So it'll engrave in your brain. You will never forget p-value. All right, let's do this one. LDL cholesterol in adult. The National Center for Health Statistics report that the LDL cholesterol for adult has the normal distribution of a mean 130 and standard deviation of 40. So that's kind of nice. I'm gonna highlight some stuff here. What is my mu naught? Yeah, 130. I have nobody say 124. That's X bar, right? So that's my mu naught. And then sigma is, this is my sigma. The medical director of a large pharmaceutical company, some guy, looked at the medical records of 72 executives and find that the LDL in this sample is 124.86, so slightly lower. Right? He wants to know if the company executives have a different mean LDL from the general population above, based on that sample. So the hypothesis here, H naught. Someone tell me what you want to write down. What should I write down? Well, you've done this before, at least 2 of them above. Okay, start out with what? Start out mu, right? Start out mu equal mu naught, so 130. What about HA? Anyone brave enough to tell me what's HA equal? Did he say less than? He said different. Well, he didn't say greater than or less than. I mean, at least in the term that's not implying, right? Not implying less than or greater than. Yeah, so when you hear different, it's gonna be implied the difference, right? So be 2 tails here, 2 tails. Assumption check. The data, the 72 executives should be simple random sample. It should be. It's just gonna be assuming the problem. No way for you to check that because they're the one who collect the data. I don't know who are they. And then the second assumption is that. Let me write out correctly. Data come from simple random sample. And then the response variable what is the response variable in this problem? Just did in your last exam. What is the response variables in this problem? Yeah, the LDL cholesterol levels, right? The LDL variable has a normal distribution. So in context, on the exam, I do want you to put in context. So the LDL cholesterol cholesterol for adults. In the the LDL cholesterol in the here I mean the 72 executive. Executive has a normal distribution. Now, it did not mention that these. I don't have data points to graph it, and it did not mention that the 72 executives there had a normal distribution. There's LDL cholesterol have a normal distribution. How do I assume that this is true? How do I know this is true? Well, this one, the first assumption on the exam, I'm just gonna give it for free to you. Just always say data come from SRS. Okay. But the second one, how do I know that the LDL cholesterol for the 72 executive has a normal distribution? Good, right? The first thing first, your population is normal, so that's you safe, right? You say, or if you want to be more careful, you say 72 is bigger than 5 LCLT, right? Central limit theorem. I assume that the sample mean distribution have a normal distribution. All right. So step 1, step 2, step 3, test statistic Z. Let me remind you the formula. Z equal X bar minus mu naught divided by sigma divided by square root of N. X bar is 124.86. Mu naught is 130 divided by 40, that's your sigma divided by square root of N is 72. 72 executives. Go ahead. Let me double check. So divided by X. I got the same. Okay. Roughly negative 1.09. And then you look it up on, oh, by the way, this is the 2 tails, right? If I was you, I would draw it out. Otherwise, I'll tell you why you should draw it out. But at least in your head, if you don't draw it out, at least you draw it out in your head. Is a normal distribution. I'm gonna assume I'm just gonna say 0. Mean is 130. Sigma is 40 divided by square root of 72. It's 130 here. Should have used different color. I'm gonna use different color, okay? Oh, darn it. Here we go. Right, 130. Okay, better. Negative 1.09 is right here. Right? Now, your Z table always calculate the probability what? From left to right, cumulative, right? It always go from the left. So if you look on the Z table, negative 1.09, what you get at? Does anyone have that? I just don't feel like pull it up. P of Z is less than negative 1.09. Negative 1.09.1379. Am I done? Oh, sorry, I didn't see that. My bad. Am I done? Can I stop? I found the am I complete the test statistic and the p value? That's probably so. Am I done? What should I do next? Yeah, the right tail, right? That's only one tail. We want two, right? 'Cause it's a two tail. So let me put right here. It's a two tail. So one more. What the value here? What do you think? This right here. What the value should be there? It's symmetric, so it should be, yeah, positive 1.09. And guess what? The area is going to be the same too, right? It's symmetric. So the area also 0.1379. So for the two tail, you need to double it. Huh? Oh. So gonna be 2 times 0.17, sorry, 0.1379. 0.2758. Now you're done. Now you're done. That's your p-value. Okay. Because, okay, so now p-value, the result. So now decision. P-value is equal 0.2758. Oh, I forgot to give you the alpha, see? I say 10%. Let's just say 10%. Is 0.2758 less than or greater than 10%? What's your decision? It's greater than alpha, which is 10%, right? 10%, which is 0.1. If it greater than alpha, what do we say? What's your decision? Look up. Yeah, you fail to reject, right? You fail. Yeah, you say same thing. You fail to reject H naught. Please don't stop at reject. Okay, a lot of people just say fail to reject and then stop. Reject what? H naught. I mean, you favor HA. So your conclusion is this. Because you fail to reject H naught is insignificant. Maybe I'll write something more. No. What color? Dark green or whatever, purple something, violet. Fail to reject. So intrinsically insignificant. Boring, right? Boring. So conclusion is there is not sufficient evidence to say that. Now I come to the context. Make sure you got the context right. Say that come to the parameter. The parameter is the true mean or population mean. Pick your vocabulary. True mean. Now comes to context. BMI. Wait, not BMI. I remember the last one. LDL. Cholesterol. What you try to prove here? You try to prove what? Oh, no, I'm sorry. I shouldn't say prove. You try to show that the true mean of the true mean LDL cholesterol represented by the 72 executive, right? The true mean LDL represented by the 72 executive. Okay, there's not sufficient evidence to say that the true mean LDL cholesterol represented by the 72 executives is different than who? Different than the general population, right? Wow, that's the last slide. That's it. I was thinking give you guys a little break and then continue. Wow. Okay, that's it. All right. Okay, so let me highlight what is gonna be. I want you to say. Okay, the one in yellow is gonna be all generic. Oh, hypothetically, just hypothetically, if I fail to reject it, if I reject it not, what would my conclusion be? Hypothetically, let's say I reject it not, say something small like 0.05, something 0.03, less than 10%, and I reject it not, and I have statistically significant, then my conclusion will be, well, there is sufficient evidence, right? If it fails to reject, there is not. Reject, there is. So I'm just gonna highlight some generic things here. Right there in yellow, and in green will be all contacts. The one in black is your decision. I don't know. Reject, there is. Fail to reject, there is not. Let's take a break, and then we're gonna have a quiz and we'll go home. Okay. You guys go home, but I still have to stay here till 8 o'clock. Bummer. Oh, that is so short. Oh, one more time. I want to check if my result correct. Okay. Or that's all handwriting. I want to know. X is 124.86. Mu is 130. Standard deviation is 40 divided by square root of 72. Low or tail. I'm gonna say true. And what I'm gonna do is I'm gonna multiply, I'm gonna double it. So multiply by the whole thing by 2. Yay, we got the same thing. So it's good. 27.77 something. Okay.